Hello everybody, hope you all are doing really well. Today we'll discuss about how to sort all zeros, ones and twos in the array without using any sort function or sort algorithm. Okay, so let's look into the problem statement. It says that given an array which consists only of zeros, ones and twos, you have to sort them without using any sort function. So let's look into an example to understand this. We have an array here and this array consists of only zeros, ones and two. That's what the problem statement here, and that's what is seen in this example. Okay. And if we have to sort this, all the zeros will come at the start, all the ones will come at the middle, and all the twos will come at the end. That's what I've tried to denote using S, M, and E. S meaning start, M middle, E is the end. Okay. So we have to sort it all in all these elements in such a way that all the zeros come in the start, one somewhere in the middle, and twos come at the end. Okay. So start of any array we know it happens at the zeroth index. The end will happen at the n minus 1 index. Right? You can see this here. There are 8 elements and the last index is 7. Okay. And then we have the middle element. Okay. So middle element, we do not know exactly where the sequence of 1 start. It's not known to us beforehand. It depends on the number of zeros and twos. You agree with me? I hope so. So M will make it also equal to the zeroth index. Okay. And our main objective will be to sort this entire array from mid M, that is mid, to the end. Okay. So I'm just making these pointers here. So you have the start pointer, this is the end pointer, here I have the middle pointer. Okay. So my main objective is to sort from M to E till this pointer comes to this mid. You can rather say that it's traversing through the entire array and it's helping you find the correct position for the zeros, ones and twos. Okay, remember that. Right. Now we have the start as well as the midpoint with the first element. Okay, it comes here. It's pointing to 0. Now it'll say that 0 should come at the lower element, should come at the lower half or at the start of the array. So we'll swap. Why are we swapping? That's because we want to change the location of the element to the correct place, right? 0 should be in the start, the 1 should be in the middle, and 2 is at the end. So we'll use swapping to make the changes in the original array itself. Okay, we won't use a separate array. So 0 is in the correct position. So we'll do a swapping with S and M itself. I mean, 0 will come back to 0 itself. Okay. Now I'll move this to the first index. That's because we know that the previous index has 0. Now, if you're getting any zeros, it should start filling from this next start position. Okay, that's why we move S. Then we move M also here. Okay, because we've already done the check for this element. Now we'll move to the next element. Now what does it say? Now we know that we have found a 1 in this place. So if it's a 1, it should come at the middle position, right? So we leave it as it is. Because 1 should be at middle, so we'll leave it as it is. Next, we move this M to the next position. Okay, so which is 2. Now we see that the number given is 2 and 2 has to be at the last part of the array. Okay, so we should swap these two. This and this will get swapped. Okay, so I'll just write it. We have 0, we had 1, then 2 is swapping location with the end element. Okay, so 1 will come here and 2 will come here. Okay, and the rest of it will remain as it is because we haven't seen it yet. So this is how it look. What have I done? I've swapped these two. Correct? 2 which was here has come to the end and 1 comes here. Okay, right. So after we do this, we know that at the end location now we have a 2, right? End location we have a 2. So we'll move this end location here. Why won't we move the mid location? Because we've got a new element here and we haven't checked for this one. So we won't move the M location. It'll remain here itself. Now what I'll do, I'll again check. This is the M, right? Start is here. Okay. Start is here. M is here. And now E has come here. Okay. I hope it's legible. Okay. Now M is 1. Okay. The element at M location is 1. So we know that 1 should come in the middle. So we don't have to do any swapping. So we'll leave it. And we'll move M to the next location. So it comes here. Okay. So once M comes here, again it's another 1. So it doesn't do anything and move to the next location. Right? So once M becomes 2, we know that it has to come somewhere in the end, right? So what do? We have to swap this as well as the end location. So that is what we'll do here. You have 0, you have 1, 1, 1, 0 will come here, 2 will come here, okay, 2, 2, okay. This is M. We won't change the M location because a new element has come to this position. You have to check for it. However, at the end, we know now a 2 has arrived, so we can decrease the end. Okay. So we decrease the end. We keep the start here. Okay. Now we come across a 0. Now when it's a 0, we know that we have to put that element in the start of the array. So where is the start location? Here. So we have to swap these two, correct? These two will get swapped. So I have a 0 here, I have a 1, 0 here, sorry, I swapped it, 1, 1, 1 here. Now I have to move the S because I know that I have filled an 0 at that position. So I move the start here. And now I move the middle to the next location because I've done the check for this element, right? So I move it here. So M and E are pointing to the same location. Okay. 2 and 2. Now, the next iteration we see that M is pointing to 2 and 2 should be at the end of the array. So we perform a swap which 2 will remain in itself because M and E are at the same location. Okay, and after that what happens to E? E will move one step backward, right? So E moves back. So when this happens, when the end moves one step more than the middle, right? Like this, you can see E is at the left of M. This is the left. This is right, right. You can see to the left of M, we have E. When E crosses M, you can see here. When E crosses M, E comes here, M is here. So when E crosses M, that is when we know the entire array is sorted. Check. You can check it here. 0, 0, 1, 1, 1, 2, 2, 2. So the entire array is sorted. So we'll use this main logic in implementing. Here you can see I've done the same thing. I've named it L, R. The start is nothing but L, the end is R, and mid is nothing but I've kept it at the same position as the start. Okay. So till mid is less than equal to R. As soon as R becomes lesser than mid, that means the array is sorted. Okay, that's what we saw here. That is what I was explaining here. Okay, here you can see E comes to the left of this mid. Okay, so that is the condition I've mentioned here. And if that element is 1, then all we have to do is to move the mid element. We did not do any swapping when we saw the element was 1. Now, if we see the element is 0, sorry, I've taken a case of 0 here. If it's 0, then we have to swap the start and the mid element. That's what I'm doing here, mid. And this is the start. And after I did that, what did I do? I increased the mid position and I increased the start position also. Both I've done. And else, I've used just an else here because I know definitely the array consists of only zeros, ones and twos. Or you can write else if array of mid is equal to 2 also, okay, to be more specific. I swap the mid as well as the last element in the array. After I did that, I decreased only the ARR. Why did I not decrease the mid? You tell me. I mentioned this before. Think about it. Okay, I'll show it to you here. Like I told you, right? So I mentioned that here, why did we not swap mid and end is because here I did a mid and end swapping. You can see that. After I did that, a new element has come at mid and I have not checked where is the exact location for that. So I won't change mid, I'll only change end. Okay. So that is why I change only R here. Okay. And this is the entire solution of how to sort all the zeros, ones and twos without using any sorting algorithm. Okay, I hope you understood this. It was very easy to understand. Have a great day. Thank you.